The fundamental component of complex numbers is the imaginary unit, and this gives meaning to the square root of -1. We define the square root of -1 to be equal to I. So, for example, we can now have a meaning of the square root of -4. That's really equal to the square root of -1 times 4. And using property of square roots, this is equal to the square root of -1 times the square root of 4. The square root of -1 is I. The square root of 4 is 2. So we write this as 2 times I. So the square root of -4 under complex numbers is equal to 2I. More generally, the square root of -a for any number a is equal to the square root of a times I. Other examples of complex numbers are the numbers 3 minus 4i, 1 plus I, 6, okay, so real numbers are also complex numbers, and -9i. The number without the I, in this case 3, is called the real part of the complex number. The other number that's attached to the I is called the imaginary part. Okay, so 3 is the real part of 3 minus 4i, and -4 is the imaginary part. 1 is the real part, 1 is the imaginary part, 6 is the real part, 0 is the imaginary part, 0 is the real part, -9 is the imaginary part. Okay, let's see how operations with complex numbers works. Okay, so we want to take the complex number 2 plus 4i and subtract from that the complex number of 3 minus 2i. The way subtraction of complex numbers works is you subtract corresponding parts. So we take the real part 2 and subtract from that the real part 3, and we get -1. We take the imaginary part 4i and subtract from that the imaginary part -2i. 4i minus a minus 2i is 6i. We add complex numbers similarly. So the complex number 4 minus I plus the complex number 2 plus 3i is real part 4 plus real part 2, which is 6, imaginary part -I plus imaginary part 3i, and that gives us positive 2i. The way we multiply two complex numbers is simply by FOILing. So 2 plus I times the complex number 1 minus 3i is equal to 2 times 1, which is 2, plus 2 times -3i. So the 2 gets multiplied by the -3 to give us -6. So that's minus 6i, plus I times 1, which is just I, plus I times -3i. Okay, so we can simplify this by starting off with combining the minus 6i plus the I. So that gives us -6 plus 1 is -5, so -5i plus I times -3i. Okay, I times -3i is we just kind of multiply this I here by this I here, so we multiply like parts. So this is 2 minus 5i minus 3 times I squared. Okay, so here we haven't really touched on I squared yet, so let's take a look at that. We know that the square root of -1 is equal to I. So that means I squared is equal to the square root of -1 squared. And we know that if we square the square root, we get the inside. So that means that -1 is equal to I squared. So I is the square root of -1, and I squared is -1. So we can now substitute -1 for this I squared. So we get 2 minus 5i minus 3 times -1 is plus 3. So our final result, we combine the 2 and the 3, because those are the real parts of this. We get 5 minus 5i. Okay, try these problems on your own. Go ahead and press pause here and work on these, and then resume play. Okay, for the first one you should have gotten 2 plus 3i, because 5 minus 3 is 2, and negative I plus 4i is 3i. Here you have 2 minus 4 is negative 2, and negative 2i minus 8i is negative 10i. And I'll just do this one with you guys. Okay, so we have negative 5 times 1 is negative 5. Negative 5 times negative 3i is positive 15i. 2i times 1 is 2i. And 2i times negative 3i is negative 6i squared. So we get, if we simplify negative 5, 15i plus 2i is 17i. And then negative 6i squared is really negative 6 times negative 1. So we get negative 5 plus 17i plus 6, and that's equal to 1 plus 17i. Okay, in order to talk about division of complex number, I need to introduce a term called the conjugate of a complex number. And to get the conjugate of a complex number, you simply change the sign of the imaginary part. Okay, so the conjugate of the complex number a plus bi is the complex number a minus bi. So the real and imaginary part stay the same, except that the imaginary part has a sign change. Okay, so for example, the conjugate of 1 minus 2i is 1 plus 2i. The conjugate of negative 4 minus 5i is negative 4 plus 5i. And the conjugate of 8i is negative 8i. Okay, so now we're ready to divide the complex number 1 plus I by the complex number 2 minus 2i. The way we divide complex numbers is we multiply the numerator and the denominator by the conjugate of the denominator. Okay, multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of this denominator is 2 plus 2i. And so what you're going to see is the way we're dividing complex numbers is we're going to be eliminating the imaginary part from the denominator. So we have 1 times 2, which is 2. 1 times 2i is 2i, so plus 2i. I times 2 is 2i. And then I times 2i is 2i squared. And then we're going to divide that by 2 times 2, which is 4. 2 times 2i, which is plus 4i. Negative 2i times 2 is minus 4i. And when you multiply a number by its conjugate, this is always going to happen. The imaginary parts will cancel each other out. And then minus 2i times 2i is negative 4i squared. Okay, so this is 2 plus 4i plus 2 times negative 1 divided by 4 minus, okay, these guys cancel out, 4 minus 4 times negative 1. So that's equal to 2 plus 4i minus 2, because 2 times negative 1 is negative 2. So the numerator we have 4i, and the denominator we have 4 plus 4, because negative 4 times negative 1 is positive 4. So in the denominator we have 8. So this simplifies to I divided by 2, because the 4 and the 8 cancel, which is 1/2 I. Okay, so 1 plus I divided by 2 minus 2i is simply equal to 1/2 times I. Okay, why don't you try this one? 3 plus 2i divided by 2 plus I. Okay, pause and work on it. Okay, so for your answer, you should have gotten 8/5 plus 1/5 I. So if we FOIL the numerator, we get this quantity. If we FOIL the denominator, we get this quantity. So then we replace I squared with -1 and combine these two pieces to get I. In the denominator, we see that the -2I and 2I cancel. As I said, they always will. We get minus I squared. I squared is simply -1. So then we have 6 combined with -2 times -1 gives us 8 plus this I. 4 minus a -1 is 5. And then we just break it up. 8/5 plus I/5 is really 8/5 plus 1/5 I.